G'day folks, welcome back to term 2. We're starting off with a review. Now it's really good when we start off with reviews of things because it means that all the concepts we're going to be covering are really easy, the stuff you would have seen before. If any of this stuff is not familiar, if you've forgotten any of it, if you didn't understand any of it the first time through, don't panic, okay? The good part about looking at this work, it's trigonometry that we're going to be looking at. The good part about looking at trigonometry is that it's a concept that we first see in year 9. Okay, so in other words, the beginning parts of the concept are easy ideas, right? So don't worry if you didn't understand them when you saw them in year 9. Don't worry if you kind of thought, oh geez, I hate this trigonometry stuff, I can't wait for that to be done with, and you've swept it under the rug and it's gone out of the memory hole. It comes back with a vengeance, okay? But don't worry about it. That year 9 stuff are easy concepts, okay? The brain's had a couple of years of maturity under its belt. You saw a bit more trig in year 10, and now here we are. We're going to go back over that beginning stuff again in year 11, okay? Let me sort of talk to you about the way I sort of come at trigonometry. When we first teach it, we come along and we basically sort of, in year 8, you sort of draw a right angled triangle, and you teach kids about Pythagoras and, a squared equals b squared plus c squared. And here's how to find this and here's how to find that. And then later on in year 9, we come back and we look at SOHCAHTOA, and we here's how to find this and here's how to find that. And here's a shift button on your calculator and all that sort of stuff. It's a good idea to stop and say, well, okay, all this sort of triangle measuring stuff, which is what trigonometry is, literally 3-side measuring. That's exactly what the name trigonometry means. All of that stuff is really one idea, okay? So if we look back and try to take stock of everything that we've seen in the past and try to get our head around it as one idea, it makes it a lot easier for us to consolidate old knowledge and then to have a solid foundation from where we can move forward, okay? So look, I've put up this basic sort of schema of trigonometry, where we've been, and a little tiny sort of hint at where we're going. So when we first looked at trigonometry, we looked at this right angled triangle stuff, okay? If we had a problem that involved 3 sides, well, that was a Pythagoras Theorem question, okay? And the question could either say, do you want to find the hypotenuse or do you want to find a short side? We're going to look at exercises where we sort of go over examples of that, but recall that that's what Pythagoras Theorem does, okay? Pythagoras Theorem, right angled triangle, and we're either finding the hypotenuse, or we've got the hypotenuse and one of the other short sides and we want to find the third side, or the other short side, okay? Then we learnt about these trig ratios. Well, they were problems that involved 2 sides and an angle, okay? You had sine theta, there's the angle, is opposite over hypotenuse, there's your 2 sides, or cos theta, there's your angle, is adjacent over hypotenuse, there's your 2 sides, or tan theta, again, theta's there's your angle, with opposite over adjacent, there's your 2 sides. So that stuff involved 2 sides and 1 angle. So we had 2 different ways of looking at right angled triangles. Either where we had 3 sides, and it was Pythagoras, or where we had 2 sides and an angle, and then it was the trig ratios. With the trig ratios, there's 3 kinds of problems they can give us. And though the 3 kinds are not a sine problem, a cos problem, or a tan problem, the 3 kinds of problems you can have with the trig ratios is where you've got an unknown numerator. So in the sine ratio, you'd be finding the opposite side, okay? Or in the cos ratio, you'd be finding the adjacent side. Or in the tan ratio, you'd be finding the opposite side, so we're finding the numerator. Or you'd have an unknown denominator, so a problem with the sine ratio where you'd be finding the hypotenuse. Or with the cos ratio where you'd be finding the hypotenuse. Or with the tan ratio where you'd be finding the adjacent, okay? Or you had unknown angle problems. You had the opposite and the hypotenuse, you needed to find theta. You had the adjacent and the hypotenuse, you needed to find theta. You had the opposite and the adjacent, you needed to find theta. Okay, so there was 3 kinds of problems in these problems that involved 2 sides and 1 angle. Okay, and if we mastered those those 5 ideas so far, finding a hypotenuse, finding a short side, finding an unknown numerator, finding an unknown denominator, finding an unknown angle, well, congratulations, you pretty much mastered all of the mechanics of trigonometry for years 8, 9 and 10. Okay, that's all there was to it, really. So for all the time that we put into it in years 8, 9 and 10, it's really only to solve those 5 kinds of problems. They came up with applications for those ideas. So the main applications we saw with trigonometry were angles of elevation and depression, and we're going to see, look at those in the next video that's coming up, and then bearings problems. Okay, where we're going from here is we're going to look at some ideas that came up in the Year 10 course that we'll probably develop a little bit further, and that's to look at non-right angled triangles. Okay, so all of this work here, the Pythagoras Theorem and the Trig Ratios, that's all right angled triangles. Then we look at non-right angled triangles where we look at not the ratios, so these, sine, cos, tan, they're the ratios, but where we look at the rules, okay, the sine rule, the cosine rule, or the area formula, the area of a triangle. Okay, and we'll again, you've seen them before, but we'll see them again and we'll go back to have a look. With those, we can have the sine rule where we're finding a side, or a slightly different version where we're finding an angle. Same deal with the cosine rule where we're finding a side or finding an angle. The sine rule involves 2 sides and 2 angles. The cosine rule involves 3 sides and 1 angle. And then the area of the formula, the area of a triangle formula, where we've got 2 sides and the included angle. Okay. Now that's not where it ends. Okay. If it was, then by the end of Year 10, you'd pretty much be done with trigonometry. We're then going to extend that a little bit further later on. We're going to look at trigonometric functions. And we look at trigonometric functions because they open up a world of very, very powerful mathematics that helps us solve problems in the real world. Now, I don't mean by problems in the real world, I don't mean, oh, when am I ever going to use this, that whinge. I don't mean that. I mean real problems that involve things that happen in cycles. So there's this thing that happens in cycles all the time, like the sun going up and down. Okay, the tides coming in and out, the wheels turning round. Okay, wheels turning. I mean, we wouldn't have like Western society the way it is now if it wasn't for the wheel. Okay, so and not just wheels, as in like sort of on a wagon, but I mean like gears and engines and all that sort of stuff. So the applications of trigonometric functions as they apply to the study of all things that happen cyclically basically forms much of the foundation for real world applications of mathematics and calculus, which is basically where we're heading with our course down the track. So really, really exciting stuff in the future, but we need to get all these basics down pat now. So in our next video, I'm going to do a quick recap of using Pythagoras to find hypotenuse and short sides, using the trig ratios to find numerators, denominators and angles. Okay, and then you'll have an opportunity to try some problem solving with those. They're coming up.